the microgrid in the box is around us enabling capabilities offshore as well. So yes, it's about access to Chinese production costs. It's about access to capabilities that complement ours to a large degree and enable us to build the next generation product. But that also allows us ultimately, once we're at the point where we want to be in terms of market penetration here in Australia and New Zealand, to then go offshore to targeted markets in Asia Pacific. And yes, we have our eyes on select few markets in the ASEAN region that we'd be interested in. And those are ones that we will be looking at in the course of the next 2 years, probably with partners in that arrangement as well. The idea behind the system, in a nutshell, is that you have a high voltage DC backbone. Again, this is in excess of 1,000 volts. We don't quite know exactly where we're going to land. There's a number of factors that actually play into that. So there's a DC backbone, which has one core AC-DC converter on it, which will differ in size dependent on the requirements of the household. And then it has DC components on it. So it will have an EV charger, which is DC. So there's a DC converter there. There's an MPPT or a set of MPPTs to enable your PV connection. And then there's obviously an inverter to connect to your battery as well as a DC-DC converter. And also, this is an interesting one, a connection to your heat pumps. What's not commonly known is that the majority of heat pumps available in the market, the vast majority, can be run without modification on 350 to 420 volt DC, and very efficiently too. And when we talk heat pumps, we're not talking just about house heating and hot water. We're also talking about the next generation air conditioning units that use heat pumps as well. So we now have an opportunity to drive your major electricity consumer, both here as well as in electrification environments where you use heating like Europe or Tasmania for that matter, or New Zealand where you want more heating. In those locations, you would be able to run those directly and control them as well. Any clipping that happens right now because your AC-DC system is overloaded because you might be using it too much for your battery or not, now allows you to basically go directly from your PV to your battery, from your PV to your EV, or from your EV to your house. So you can now run all of that on your DC backbone with minimal losses and maximum use of any energy generated or used in the household.
So these are modular and scalable, of course.
That's correct, yes. So the system is fully modular. All of these components are modular. We will initially focus on the household. So the first release will be will be in prototype and field testing early next year for release planned for late 2026. But that's focused predominantly on household requirements, so up to 15 kilowatts, 3-phase, and with batteries up to 50 kilowatt hours connected to that. There is a plan to then move into commercial and industrial, the same basic idea behind it. There's obviously different use cases here and slightly different deployments, but that will be going out in early 27 as well. Within our partnerships with Ambibox, there's other partners that Ambibox has as well. One of them is a company out of Finland that they do bidirectional. They use the Ambibox bidirectional chargers as well, so that their power electronics from Ambibox and their own HMI on top of that. And one of their customers actually is a company that builds ski-doos, I think they're called. And they produce those. And by the way, they're 15118-20 compatible. So they're bidirectional. And we asked them why, and they said, there's a lot of customers who actually have a house somewhere in the wild, might be a timber house, a block house or something like that. The only heating it has might be wooden and the wood fired burner or something like that. That's all they have. And they don't have options for light. So then what do? You part a battery back and forth. That's pretty useless. But hold on for a second. Now you've got an electrical option here where you right out there, you plug it in and all of a sudden you've got light. You can cook, you can do whatever you want. So those use cases in the cold work obviously just as well in the Philippines, in island nations. They would work just as well wherever you are isolated and don't have a grid connection. And you might be able to ride your electrical ATV out, connect that, and then have power. The interest we're getting for our bidirectional charger are massive from councils. They're massive from local government organizations here in Australia that are looking at this and are going, okay, what do we do if, for example, Alfred hit, right? And then parts of the Brisbane surrounds had no power for a week. Those parts might have a government-run clinic. They might have a government-run office that you actually require for your emergency response. But these guys have no power. And when you look at Energex and you look at Ergon as the local DNSPs, they have a limited supply of generators they can actually put in place for these types of situations. And unfortunately, not sufficient to cover off all the needs. They were saying, great, as we electrify our fleet, So all their maintenance personnel, their facility staff is electrify that fleet. Now you have an option of saying, great, we're just going to take one of our trucks. We're going to drive it to the clinic in the case of an outage. We're going to connect it and we can power up the clinic. So we can use obviously all the electricity gear. We can ensure that our vaccines or our other medicines are actually refrigerated. So we can actually treat patients and we can work as we need to in a situation like that. So that's here in Australia. And I suspect these issues, they're pervasive across all countries. One thing to note, though, initially, as we develop this and as we roll it out, it will be targeted cost-wise at nations like Australia. So this will not be cost competitive for situation developing nations at that point. But I fully expect the cost to drop quite significantly over the first few years of deployment. And at that point in time, it would become a viable option for other countries as well. So that's here in Australia. And I suspect these issues, they're pervasive across all countries. So removing diesel from what are currently diesel-powered remote communities and enabling remote use of renewable energy.